So welcome to the Components Are Not Enough talk. My name is Andreas Graf, I'm from EclipseCon, and the talk has been designed together with Samira Salman from BMW. She cannot be here, so Ralph is very disappointed that she's not here because he wanted to raise the quota of women. So he said, I should have stayed at home and she should have come instead. But it's a pity. So just a two words. I think a lot of you already know EclipseCon. We're a strategic Eclipse Foundation member, and if you ever have come across the open source project Xtext, that's basically our poster project where everybody knows us. And we do a lot of software tooling based on Eclipse for the automotive industry. And what I'm going to present to you today are the current activities and results in a research project that is publicly funded that we do together with BMW and other companies like Fortis, Symtavision, and yeah, now I'm having a blackout. There's one more company, and I will tell you, it will come to my mind during the talk. Okay. How many in the room are from the automotive industry? Okay. How many are from aerospace? Okay, much more. So, situation in automotive, I think, is quite similar or comparable to aerospace. Today's cars are actually more than basically they are driving networks with wheels. So if you look at today's BMW or Daimler, you do have up to 70 or 80 little computers, ECUs, that are actually connected over bus systems, different bus systems. There's CAN, LIN, FlexRay, now there's Ethernet. So that's a big complexity. And what's happening right now is that the automotive industry, they are really hardware-oriented guys, very often. So the focus in the engineering is often an ECU in the car. So they think in ECUs. They order an ECU at Conti. They order an ECU at Bosch. So a lot of the thinking is based on those components, basically. They think of that as in components. Well, that raises an interesting problem. So, who of you actually own one of those modern economic cars that actually switch off the motor when you stop at a red light? Okay, this is more. Last talk in Germany, there was none. it's getting actually better. So now that's very, very interesting. So, for those of you who don't know it, you drive up to the red light. If you have a manual transmission, you put the transmission to neutral, the motor shuts, and as soon as you press the pedal, the motor starts again. It's interesting, but there's much more to it than meets the eye. If you look at such a function, you see that you have the gear shift, which I just mentioned. If you put it into neutral, you have some ECU that decides, should I turn off the motor? And then you have an ECU for the motor that actually does the turning off. So, but what you don't see is, for example, that there's also an ECU that's taking control of energy management. So, if your battery is low, if your climate control is on high, if you're driving southern France 35 degrees and having like 10 degrees in the car, it will not switch off the motor. And in addition, there's a door sensor. The door sensor is actually also involved in the start-stop function. Have an idea why? If the driver leaves the car, there's a safety requirement that the motor should never be activated when there's no one in the car. So as soon as someone opens the door, the complete functionality is shut off. And that even goes on. There's a sensor in the hood of your car. So if someone opens the hood doing service, it must be made sure that the motor does not come on while someone is having his fingers in your motor. So what you actually see is that one simple function, what is sold to the customer or end-user function like start-stop, is actually distributed over a number of ECUs. And that raises obviously a problem, because you know that Conway's law, the architecture of the system is reflected by the organizational structure. And the companies today, they reflect the structure of the ECUs in their organizational structure. So if you look at the car company, you have departments taking care of the drive, of the motor, of the interior. And so each of these components will be owned by a completely different organizational unit in the company. And then, coming up to that, it even gets worse. All those departments, they do have different suppliers. So the motor control engine might be supplied by Bosch, and the engine doing the braking, checking if the brake is on, might be supplied by Continental. So there is also a huge complexity in terms of how the suppliers are structured. So, and that's giving the automotive industry right now a really tough problem, because either they do not have yet implemented a functional owner, so there is no one taking care of an end-to-end function, or there is one, and he is really a poor guy, because all of those departments, they do have different IT systems. There is a lot of work to be done in getting an end-to-end view on the function. And this is a statement from Daimler. So we do have some functions in the car where 20 or more ECUs are involved. And you can imagine what that means if you are the owner of that function. I mean, you're not the boss of anybody in working for your function, but you still have to hope that they all will help you implementing that function. So there are several activities now in the automotive industry implementing a function-oriented view, where you go from looking at the ECU to looking at the end-to-end function as a central engineering artifact and concept. So that's just different aspects. I mean, we have seen that I've shown you how the organization is affected. So they will have to implement new structures, implement function owners with the correct competencies and the possibility to actually influence all those people. We do have a different process, because we have to start with the function, thinking who is also involved. Because right now, often it happens in the automotive industry that the first thing that you start with is a software architecture. But that's way down the V model. So you have requirements and you have a software architecture, but there's nothing in between having a logical view. Obviously, you need tooling for that, because process tooling always goes hand in hand, and methodologies like new standards. And that is basically, so what I'm focusing on today is the tooling, because you can, I mean, each of those 4 bullet points, you can easily talk 2 hours and more. It's a big, interesting field. And what we're doing in the EMAS research project with all those partners is that we are implementing a tool chain. Surprise, surprise, we are the only research project in the world that is implementing a tool chain with the aspect of with the focus of that. So all is Eclipse based, and we have a combination of reusing and combining Eclipse projects. So at the top, we start with the requirements tooling. Basically, we are using Eclipse RMF, which is a open source implementation of the REC-IF standard that has been put out by automotive industry. It's an interchange standard for requirements, which is also going to be supported by IBM doors, by PTC Integrity, by Polarion, etc. So this is really working, and what we're doing is basically using that as an import for simple viewing and showing editor. So the core of that is from EclipseCon, and the editor on top of that is from Formal Mind from Michael, where there will be a talk in the afternoon. Then there was a really small project by Pure Systems. They have a tool for variant management. It's the Eclipse feature model. Was dead for a long time, and we were putting new life into that by providing editors for the feature modeling, and that is also already available as open source. So that's basically where you start with your modeling, and then comes the big gap where we didn't have a lot of tooling up to now. That's the logical architecture. It's looking at, for example, saying I have a function that detects if the driver is in the car. I want that function, but at that point in time, I do not yet have decided, is it in software, is it in hardware, do I use the door, do I have an inside camera? So that's logical architecture, and we are building on the new project proposal. It was out yesterday from Conti. It's called EclipseCon. I will have a slide, and you can have the slide listed with all the projects. And that supports modeling of logical architecture and safety aspects. So you have error propagation models in there, you have the goal structuring notation for arguing if your safety aspects are really met, you have timing model in there, etc. Okay, then often you want to have first function definitions on such a logical function, and what most of the industry uses is a tool that is not Eclipse-based and is very expensive, and we don't have a license for that. So there's an Eclipse alternative called Damos, which is a block diagram editor, including the simulator, where you can actually have those measurement control. So it's does anybody know what's Regelkreis in English?
Control loop.
So it's
Control loop.
Control loop, yeah. So you can model the control loops, and then comes the software architecture and the ECU topology and deployment, and we're using the automotive standard AutoStar for that. That's community-based, so we're reusing that and put graphical editors on top of that to be able to show all of that. And then one of the most important aspects is traceability, and we are in the process of putting out an open source project for traceability for Eclipse called Crema. It takes a little while because management is deciding what to put open source and business model, etc. But I will show you in a second. And we are using an integration with Mylan for change management, and that's great for demonstrations also. If you show that to an OEM that your tool actually refactors all the windows, if you go back to a task, it's fantastic, and it's really fun doing that integration. And one of the big aspects is the so-called trans-company model repository, because right now what happens is that the OEM writes a requirement spec, then he throws it over to the first-tier supplier. It's like a big wall, and they implement it. In fact, it's DOS exchange, but basically that's what happens. And we want to come to a more agile process, and so we are working on putting all of that on top of Sphinx and CDO, so that we can use the functionalities of CDO for having either a centralized repository or a more, I'm saying, a Git-like workflow for models, because CDO does branching, versioning, etc. So, for those who know the implementation, just what's going to happen here. We'll come to a demo in a second. So, RTOP and eRTOP are based on the Eclipse project Sphinx for workspace management. The requirements RMF is currently directly on EMF file resources, and Sphinx also does work with EMF file resources. And if you talk to the automotive industry, they say, ooh, my requirements, my functional models, they are critical information. We need a 3-tier architecture for that to make sure we can have authorization, so that no one from, excuse me, lady, from China is going to look at our data and do a copy. But that's basically what they want to do. So currently within the EMIS project, we are refactoring the Sphinx projects right now, so that we have the possibility to store all those models either in EML files workspaces or with the CDO project, and then we can have 3-tier architecture with Oracle, NoSQL, etc. in the tool. So basically what we've started, or where we are having the editors, what I'm going to show you, and currently we have already refactored Sphinx, and are working with Eike Stepper from the CDO team to put CDO under the hood. Okay, so technically we're an x86 company, so we have a DSL for describing all the editors, and we're not doing a lot of hand coding for the editors. We're creating the EA top editors. So we're creating the analysis editors, the AutoSAR editors, the error model editors out of DSL specification. Okay, so that's the end of slide. So what I'm now going to show you is a tool demo. You have seen the basic structure, what it all is, and now it gets a little bit difficult because as all of you might have experienced tool demos with Eclipse based on a little resolution. Eclipse likes big resolutions. But anyway, so we will start with the requirements. So we have the requirements model in here, and what you're seeing is the Eclipse RMF project here with the editor of ProR, and you will see a lot more of the functionalities and what you can do in the talk by Michael and Atos in the afternoon. So this is, from the scope, this is very small, so it's only to describe the tool functionality. You see that we have some requirements on the vehicle states, and then we have a major requirement showing that we have an eco start stop function, and some sub-requirements. Okay, that means that the car should consume as little energy as possible, and then the car should deactivate the motor if standing, etc. So in our requirements, we also do have some information on safety. So there's the SIL level, basically, that's saying how much damage can be done, and so we're saying, okay, the eco start stop system has a very high SIL level, which is called D, basically, just to make sure that we know it. And then comes the connections to all the other artifacts in the development process. So I'm on requirement 5, and I've already prepared traceability through the project. So this is the tracing view. And on the right side, I can see all the traces, I can filter them. And for example, for requirement 5, I see that there is a logical function traced. So there's a logical function implementing or satisfying my requirement. And the framework is extensible with the plug-in mechanism, so you can easily plug in traceability for your own tool. We do have Papyrus, Xtext, AutoSAR already prepared, and then obviously you can start a navigation. And just by double-clicking through the requirement, you see, okay, this requirement is then here at my logical function. And the requirement tracing is also evaluated in another way. We have seen that function is allocated to a safety-critical requirement. So we have the documentation view here that takes the comment, the description that the implementer has put in, but it also goes ahead and traverses the requirements hierarchy and says, okay, be careful, this logical function came from a safety critical requirement, so you don't have to reduplicate the information everywhere, it just traces, it goes and traces everything here. Then it goes on, we see that that function again is associated with a software component, and if you double click, there's no diagram for that because it's a stock AutoSAR function, and it traces basically to the AutoSAR function again with the SIL level specifically shown. The entire tracing framework is completely configurable, so if you have your own standards of trace types, etc., you can just add them here. So for our example, we have satisfy, allocate, implements, and you can bring in whatever your company wants. You can have additional information. Let me see here, for example, you can see we can define which are the end types. You see that we here have different providers. That is one of the basic sets. You can have traceability to code, to C, to Java, Eclipse tasks, the task management system. And the nice thing is when you have the integration, like tracing to Eclipse C, we have listeners registered. So if you modify the C code, it notices, okay, the part is changing. You can trace to a function itself. It listens to the abstract syntax tree of CDT. So if you trace to a specific procedure and rename it, the tracing framework learns about it and updates the traces. What you can also do is obviously then stuff like reporting. There's the BERT engine behind that. Doing the reporting, you can export it into Graphless. And you already have a graphical view about the traceability. You see it in the small window here, so if we make it big, you see that the requirement is traced to the start-stop. And if I click on the start-stop, it updates the hierarchy, and you can graphically already view the entire tracing hierarchy. So next, what I wanted to show you is the entire feature management. So, as I said, we are based on what Pure Variant started, and we have put out Xtext editors for the feature and variant model. So, assume that we have a feature model for a car. So, feature modeling describes the product lines, the possible product lines of my car, but it also applies to any type of software. And I'm saying here, like, okay, in a car, I have a group that is a motor, and I can have one or two of the sub-features. And sub-features are electromotor or a petrol-driven motor. And I can have one or two because I want to model super modern electro cars or hybrid cars, etc. Then I have a group where I can just have one or the other, so I can have either manual or automatic transmission. Or I have a group where I can have something or nothing. I don't know if there's still cars without a radio, but let's say that you can have no radio, a simple radio, or a hi-fi. And we do not only have Boolean features, it's also possible to describe variants in terms of variables, so we can have a petrol motor with different capacity here. So that's how you describe the space of configurations that is actually possible in your car. And now, in one of the early in the early implementations of start-stop systems, it was only available for manual transmissions, because that was how it worked. You put out the gear, and then the motor stopped, and they didn't know how it security, safety in automatic transmission. So that changed, but let's assume start-stop is only available in manual transmissions. So that means that I must, in my requirements, I must somehow say that start-stop is only available for manual transmissions. So we have a textual grammar here where we can actually put conditions that are evaluated on the feature model. And I'm saying, okay, I'm using that feature model, and then I'm saying this requirement is only valid if I have a manual transmission, and obviously this is all connected through the Xtext framework, so you get the syntax highlighting, code completion, etc. here. So now I have described basically my feature models, and in the automotive industry we often say 150% requirements, so it's more than for just one car, it's for all the product line. And now I might want to see what is specific, what does my requirement structure for a specific car look like, and then obviously I have to describe what the specific car is, and let's assume we have a BMW X3 hybrid car with automatic transmission. So I'm referencing the features, and then I'm picking the features that are actually in the car. So here again with syntax highlighting, etc. I'm saying, okay, I have a petrol motor in the car, I have a electromotor in the car, and important, I'm selecting the automatic transmission. It's important because we saw the requirement only applies for the manual transmission. So, in the next step, I can then go to the requirements diagram or requirements file and say apply a specific variant, and then I pick my let me see, I pick my X3 BMW, and I have to say where the condition is, and then it says okay, I'm applying that variance to the Reclipse model, and here it removed the eco start stop, because we said eco start stop only applies to manual transmission. I'm saying my BMW has an automatic transmission, eco start stop does not apply. And then I do see in the diagram, okay, that an error has occurred. Okay, it creates system requirements variance. It's a different view. It's not a new set of requirements. In Reclipse you can define different views. It's the same set of requirements with a different tree. And then I can click on that, and you see that I get a new view where the eco start stop is removed. And that then continues. So basically the same thing applies if you look at the start stop function. This is now just for demonstration purposes. I do have the variant icon here, and again I can put under the logical functions, I can again put conditions when this function is actually in the system or when it's not in the system. And at that point of time, let me see if it's working. I can also say apply variant here. I'm picking again the configuration of the B. Okay, and you see what we do is graphically it gets gray. So showing, okay, you have chosen a configuration where we do have that function, but actually it's grayed out now, so that you can have a view on what the entire system actually would look like in your specific configuration. Yeah, so that's basically what I wanted to show you. We do also do a little bit of additional stuff around that, so experimental things. So as you know, there's a talk about from Zigazi today about hardware definition with VHDL, FPGA, and that's not working here in the demo, but you see that we also have an example where we put in VHDL files to traceability to VHDL, then the source code, etc. And that's basically what's currently happening. So I think the time is basically up. I think we have until 35, don't we? Yeah. Okay, then we have another 5 minutes for questions. Yeah.
Yeah. Can you put some accessibility link with a Simulink function?
Yeah. So what we do is what you can basically do is link to anything in the file system. So that's the simplest thing. And what we also have, we haven't done it here with the integration, but we can pass MDL files and put MDL files into a specific eCore format, and then you can trace to MDL. Yeah. Mm-hmm. Yeah.
Yeah. At the logical view for architecture,
mm-hmm.
Why not using C7 as it's at the system level? Is there a special reason? Is it just for automotive? Or?
No, there's no special reason. It's because there's a reason. So there is East ADL for automotive. The automotive standard has brought it out, and we wanted to actually experiment with the standard. Okay. So it's perfectly valid to use SysML
or customization of SysML.
Or customization of SysML. There's a number of standards that I do not want to say collide, but actually provide similar things. It could have been done with a UML profile, but it's just a decision to actually try that So Conti brought out the EDAL standard, and we wanted to, as in a focus of the research project, learn about it so that we can actually evaluate, understand it, provide feedback. So that's it. Yeah. So, yeah.
Oh, sorry. Have you finished answering?
Yeah.
Okay. You said the function could be spread across several ECU.
Yes.
Does the tool provide a way to see that the composition of a function?
Yeah.
From function to what ECUs are implemented?
Yes. So what I didn't show here, because my example is right now broken. We do have a topology view, basically where you can model the ECU topology, and you associate the software components, you deploy them to the ECU, and by the traceability you can then see, okay, this function is implemented by this software component, and then it's implemented on that ECU, and we then have a faster view where you don't have to go follow the links by yourself, but where you can see, okay, just like as it showed, basically the backward link where it shows which requirements that you have, we can have a forward link showing which ECU that's, or which ECUs this is actually deployed to.
And just the reverse question, is there a reverse view where you can select an ECU and see all functions that have...
Exactly, yeah. So this is not a product, it's more like a research project also for our partners to understand how to work with East ADL, to show what it could look like, what the industry would need basically right now, because in terms of a research project, often the budget is so not that you can actually finalize it, because only if you look at the AutoStar standard that we are using, that is so huge. I mean, for AutoStar, what we're using right now, we're using sender-receiver communication, we can model that, but AutoStar has several communication paradigms with a lot of configuration options. You cannot do that in a research project yet. It's even hard to do it for commercial vendors to actually be able to produce all of it. Okay. Any other question? So then just let me quickly point out, so what we didn't go into is the actual implementation stuff, like C, etc. C is, C can be, I hope I don't offend any C fanboys right now, it can be a horrible language with all the macros, etc. And if you're interested on what you can do with modern languages, modern model workbenches, I would like to also point out my colleague's talk from Bernd Kolb, Embedded Software Development with C for the Next Decade. They have a great tool, the Embedder Workbench, where they have a more abstract C that also relates to state machines. You can see code and state machine in a projectional view, so there's no model transformation, it's all one of the same models. It's very impressive, very innovative, and I think it will be an inspirational session to attend. So thanks for everybody, and thanks for...